my old friend Will Smith
Hello.
here to talk about Ryzen 5 and Ryzen 7. Of course, Zen 5 reviews. Our review did not run this morning as expected, along with everybody else's reviews. And we did this out of an abundance of caution because, as a longtime hardware reviewer, there's a lot of decisions that go into being right rather than being first or being on time. And we frankly would rather be right than to simply be first. And of course, after seeing all the reviews of other fellow YouTubers and other print reviews on the web, we've decided to go ahead and go live to talk about what our results show and kind of what goes into the process to show you basically how the sausage is made in some ways, and then also go into the reviews, the results that we have that we think we're probably more comfortable showing now than we were yesterday when we basically said, "Oh yeah, let's think this over again," because I think the process for reviews, when people understand what goes into the decisions that are made into them, can help, if you understand them a little more, give you better insight into how reviewers actually do things. But we basically have results from our Ryzen 5, Ryzen 7 review, and I'm gonna back it up a little further. I actually had been busy doing mobile reviews, so Adam had been doing testing, a lot of fresh testing on basically the Zen 5, Zen 4, as well as refreshing his 14th gen reviews for this review process. And then I sat down yesterday and I was getting ready to cut a review to run this morning. Actually, I guess a couple of days ago. And I was looking at the results and the numbers didn't quite match up to what I expected, and also what, frankly, the sanity check numbers that AMD had provided. So if you don't know, typically hardware vendors, and this goes from Intel to NVIDIA to AMD and to Qualcomm to everybody that makes hardware, they generally will provide what's called a sanity check number. Basically, like, hey, you should be able to hit this performance. This is the expected performance out of this chip. If you don't hit it, please contact us. Or, like you may want to, or look at like, hey, there may be some things you want to look at because this is what we think you should be able to get out of your part. Well, our results, frankly, we can go into, you want to do slide one here, Will?
I was going to say, like, the sanity check numbers, just to be clear, these are, hey, there's a bunch of moving pieces that go into testing this stuff. And we want to make sure that there's no, like, you didn't miss a BIOS update, or there isn't some setting in the BIOS or some driver that you didn't install that's going to make the 10 hours of testing that goes into each CPU a waste of your time and make you have to do it over again. So anyway.
Yeah. So like oftentimes sanity check numbers are provided, not even for publication. And it's just simply so you say like, hey, this is the number we got out of this benchmark that you may like to calibrate against. AMD did provide quite a bit of numbers across many different benchmarks that you could look at to compare to, so you could see if your numbers are. So basically, this is the first one. This is Maxon Cinebench 2024 multi-threaded performance. You can see basically at the top in that lighter red is the Ryzen 7 9700X, and the bottom is a Ryzen 5 9600X. And just give you a little bit more information, this was tested on an ASRock X670 Tai-Chi board, 32 gigs of RAM, DDR5 6000 MT, and let's move the spreadsheet over a little bit, with a 2 terabyte Crucial T700 Gen 5 SSD in Gen 4 mode, a Corsair H150i all-in-one cooler with the fans set to manual 100%, a 4090, an MSI 4090 graphics card. The rest of it doesn't matter that much.
I think
but
the
basically
iGPU is on if you care, but that's the main stuff.
Yeah, IGP is on both of them. And then also, and for the Intel parts, it was using a Gigabyte Z790 ORS Pro with essentially, similar 6000 MT Patriot memory, same as the ASRock, and as well as the same SSD. You basically match the components across both of the test beds. You run your numbers, and then, so here's the first results we got. And this was a real head scratcher to me. And you can see probably why I was like, wait a minute, what is up with this? This is bizarre because we got 1100 out of our Ryzen 7 9700X, and the previous generation part, the Ryzen 7 7700X, basically is with margin of error,
Yeah.
like 1084. Like,
This is the multi-threaded test in Cinebench, just for people who
Yeah.
aren't. That's what NT
yeah, for
is,
people who don't
and
know, this is
threads.
across
Yeah.
all cores, all threads available on the CPUs. And, somewhat similar, a little bit better, but not that much better for that Ryzen 9600X part. And I don't have the AMD sanity check numbers in front of me, but we were a good 10% off, I believe, of the AMD numbers. And it was like, wait a minute, this makes zero sense. Why aren't we getting the same performance as AMD? Sanity check numbers, this may indicate that something is just simply wrong with our results, which again is a nightmare for a hardware reviewer because typically you're sitting there at 2 or 3 o'clock in the morning. You're like, these numbers don't make any sense. And then you may not have compared the numbers till the next morning, and you're like, this doesn't make any sense. Why is this newer chip, Zen 5, basically no faster than a Zen 4 chip?
Yeah.
So
At which
this
point
really,
you get on the
at
phone,
this-
right?
yeah, we got on the phone. We start talking like this makes zero sense. I was Adam, and I will say, it's unfortunate for Adam because he's on vacation, on a long-awaited vacation, because he's been obviously busting his butt here at PC World, doing all the great videos he's been doing, and it's unfortunate we ruined his vacation because it's like, yeah, what is going on?
Yeah.
And it's like, well, is it possible the cooler was a little off kilter? But then we thought about that, and it's like, the odds of the cooler being misapplied on not just one chip, but also the second chip is extremely unlikely. And just so you know, all the results here are fresh. So the 9700X and the 7700X and the 7600X and the 9600X, those are fresh numbers. So the odds of only getting it wrong on the newer parts made zero sense. And we're like, we kind of ruled that out. Talked to AMD. They said, yeah, your numbers are far off than what we'd expect. Basically, it's just slower than what we would expect. So then we sort of we made a decision, unfortunately, unfortunately for us, because you basically have to be faced with the reviewer of throwing away, 20, 30, 40 hours of testing, because you would, again, if you're responsible, you would rather be right rather than just simply have a number and hit a deadline. And I know that's the worst thing ever, because as someone who wants to hit deadlines, you always want to be there. You always want to get the numbers out. You hate missing out and not having anything. But if your numbers are simply wrong, then I would rather be late than to be wrong, because if it's going to misrepresent the product and what we expect, then it's simply the right thing to do, I think.
Well, so the interesting thing is, it's only the new CPUs that are affected. The old CPUs line up with the old performance numbers. So when we compare to numbers, I don't think we have a slide for this, but we ran Cinebench 2023 on one of the new CPUs to compare it to the Zen 4 numbers that Adam ran last year, and within margin of error. So in this case, if you see a 2% difference between what AMD gives you as their sanity check numbers and the numbers that you're getting, you assume that maybe the SSD they chose is a little bit faster than the one you're using, or something, maybe it could be memory timings are a little bit different or something like that, right?
Yeah.
But 9 or 10%, which is what we were seeing pretty consistently across the board, only with the new CPUs made us think that something was up with the platform that we built. And it's interesting because usually when CPU vendors send out new CPUs to test, don't they usually pair it with motherboards as well? You get a new chipset, new motherboard often, or no?
It depends on generation to generation. There have been times where, because the boards and chipsets are so new, you will sometimes get the board with a CPU. That creates, actually, for the vendors, hardware vendors, the CPU vendors especially, it creates internal tension, because then you have vendor B going, why didn't you send my board out? Why did you only send their board out? You're favoring them. So it creates a mess for them. But oftentimes, as a reviewer, I kind of sort of prefer that sometimes because, especially on a brand new chipset launch, or again where you're tied with brand new memory, DDR5, you want to be able to at least get the CPU to present itself to what you would expect
Yeah.
You would get. Now, oftentimes, again, I'm sure AMD is like, hey, you know what? The AM5 is not really new. Basically, they sent out the chips, run the new latest BIOS on it, you're good to go. And that was basically the guidance from AMD on this round. And over the years, sometimes you get a board, sometimes you get board, memory, and CPU. Sometimes you just simply get the CPU. So it just sort of depends on the launch cycle and how the chips fall on it.
So, do you want to go through some benchmarks, or you want to talk about what we found? What do you want to get into next?
Yeah, I mean, let's keep going because again, so against this background, so I just want to let viewers, like the reason why we said, like, you know what, because some of the other numbers look quite good, and I was like, well, then we had a discussion like, what do we do? Do we try to like remove numbers that we think are just simply way off? Or does that get weird because we just simply don't know how many of the numbers are polluted because we don't know if it's a misconfiguration problem. We don't know what it is. Ultimately, again, we decided let's just hold the whole thing. We'll have to retest these parts when we have time. But there was no way at the point where we made the decision to hold it that we were going to make the embargo anyway. So we decided let's just hold it and do a retest because we'd rather be right. But let's click it over to the next slide, which is Cinebench 2024 single-threaded performance.
So that's this one. It's worth. I said this before, but it's worth iterating again. Like a loop for a full test loop for all the benchmarks we're going to go through for one CPU is about 8 or 10 hours if you go as fast as you possibly can. Everything goes well. Right. Each test gets run multiple times. We average the results, throw out anything that's really far off the median or off the average. And yeah, it's not like we could go through and retest everything from scratch in the time we had, because we also only do it on one machine, just so there's no differences in BIOS or memory chips or whatever to throw things off. So anyway, on with
and it worked out well for this generation because you have, basically Intel and AMD CPUs conveniently all fitting into two boards.
Yeah,
that really can get a mess when you're like trying to compare previous generation, and where you're running 3 parallel or 4 parallel systems, and it gets even messier. So, but anyway, let's continue on. If you look at the Cinebench single-threaded performance, this is Cinebench 2024. This actually is much better. We're still slightly off. You never get exactly the same thing, but we were within the margin of error and something I was pretty comfortable with. And honestly, if you look at gen to gen, this looks pretty good, right? Because you're looking at that 9700X versus that 7700X. That's I think about 14% improvement where you're looking at Zen 4 to Zen 5. That is like, okay, that's kind of like what we've been expecting. We've had months and months. They've been talking about this since Computex. So this looks like what we expected. This made me feel a lot better, but at the same time, multi-threaded performance was not quite there, and if you compare to Intel, it's pretty decent too, because they're basically right there with the 14900K, and that is again a very high power part. So again, this looks pretty good, but again, the multi-threaded performance was just something that just kind of made us go like, oh God, what the hell is going on? But the Cinebench is like, okay, this looks pretty good. And again, if you're looking at gen to gen, you're looking at 14%, which is a very decent, improvement. I know a lot of people want to use the IPC term very loosely. I've had it beaten out of me by Intel and AMD to not really use that term because I'm frankly too dumb to understand what that even means. In the old days, IPC was used very differently than it is today. But, to me, what it generally means is, single-threaded performance generally means you're going to get better performance out of a lot of lightly threaded tasks, which is going to generally apply to a lot of gaming, a lot of browsing, a lot of Photoshop, a lot of applications that are, largely lightly threaded. So this is pretty good. pretty good performance.
Well,
So
and it aligns with what we expect, knowing what we know about the reduced power requirement, the power draw on the new process, and like should give them more thermal overhead for higher boost clocks and stuff like that. So you'd expect better single threaded performance. Should we go on
Yeah.
to the next step?
yeah, let's do the next one. There's not too many slides to go through, but we're going to keep going. So this is Open Data Blender 4.2.0. It's basically the canned benchmark you can run from open data for the Blender benchmark, and it's Monster Junk Shop Classroom, and this is a multi-threaded benchmark again, you can again see where we go from oh, okay, single threaded, looking pretty good. Here we are again, where 9700X versus that 7700X is that's margin of error improvement. It's a little bit faster. But same thing for 9600X versus 7600X. You're I'm not feeling too great about this. This is really, again, kind of one of the things that makes you think something is just weird going on.
Yeah.
And it is Will, you did mention something that is a really good point. It's well, AMD is, the one thing that I do think people are really kind of missing in all this, which can make you feel a little better, which might make me feel better if that was the messaging from AMD originally. But 9700X is a 65 watt part, and the 7700X is what, 105 watt part. So you are basically getting a little bit better multi-core performance at a significant savings in power, right? So
Yeah.
that's a good look if you want to look at wow, you're getting a lot of multi-threaded performance, and also you're doing it at a lot less power, but at the same time, I expected more performance out of multi-core performance to basically see it almost basically the same. Again, this is kind of saying something just feels off looking at Cinebench 2024 and looking at the Blender benchmark here, because on all core load, I would have expected the performance to be a little wider here. So it's just, again, it's just it's something that contributed to frankly, for me, the Blender benchmark and the multi-core performance in 2024 are the things that made me go something is wrong with our chips, our boards, our configuration. Something is just weird. So, but be it as it may, the big problem for AMD here is if you're comparing it to the Intel parts, Intel does definitely have a nice lead, especially when you're looking at 14700K part, right?
Yeah.
You're looking at eight cores, 8 performance cores, 12 efficiency cores, and it easily stomps on that 8-core Ryzen 7 9700X part, and they are somewhat price competitive. So yeah, sure, the multi-core performance is not there, but again, I just want to mention that this is the kind of thing that made me go we may want to retest these things because something did not feel right.
Yeah.
So anyway, next slide.
Yeah. So now we're on to Handbrake, which is another super multi-threaded.
Yeah, generally more cores are better. We're doing basically 4K AV1, 4K HAVC, and and the bars should be shorter here. So
Yeah,
shorter is
faster.
better.
Yeah.
Shorter is faster. Looking at 9700X versus the 7700X, it's not bad. It's not bad. And looking at 9600X versus 7600X, actually that's a healthy improvement for that the Ryzen 5 versus the older Zen 4 Ryzen 5. But again, that Zen 5 Ryzen 7 is
It's
not
a little meh.
Yeah, it's a little meh. A lot of it was if we had gone ahead and just simply run it, it would have been yeah, multi-core performance is kind of disappointing. Single-threaded performance is looking pretty good, quite impressive, but that lightly threaded, that heavy all-core performance is meh. Yeah, you're getting a good power savings, but it just didn't feel right. So,
well, and again, this is the place where you look at the numbers and you're something's not quite right. We got to figure out what's going on. So,
yeah, and again, it's against this Intel counterparts, price competitive. Intel, has a decent advantage. Again, they use a ton more power, and they also give you more cores, and it pays off in Handbrake. And AV1, of course, is SVT AV1. These are CPU encodes, and SVT AV1, by the way, is made by Intel. AMD though does reasonably well here, arguably because They have AVX 512, which can contribute to some of their performance. But again, I still like, yeah, gen to gen performance is the thing that kind of bugs me a little bit here.
Well,
So.
and then this is all obviously there's a larger issue with the Intel 14th gen that we're not getting into at this point yet. I mean,
Yeah.
that has to
Yeah,
factor
no, I
into
mean,
this as well.
you just simply can't run into the arms of Intel like the old days. Like, oh, I don't know what the hell to do, right?
Yeah.
But let's keep going.
Okay.
Because we got a few. We
Yeah,
got
yeah.
well, I don't know how many. What, 15
There's
slides?
a bunch
or
of
something?
slides here. Yeah.
We got this. So this is Push Bench 1.01 extended Adobe Premiere Pro. Basically, it's running a scripted Premiere Pro run, and
Real
it's quite a
life
bit different.
workflows, right? This is
Real
like,
life,
yeah.
real life, and again, you're looking at what is
This is longer is better, just so people know.
longer is better. Sometimes more cores are better. Sometimes it's lightly threaded. Sometimes who knows? Again, Adobe products are very old. It's essentially like a stew at this point. There's a lot of really, really old code in Adobe Premiere and a lot of Adobe products. But this again, like you look at gen to gen 9700X versus 7700X, and this is not incorrect. This is an average of multiple runs. It's 9152 for 9700X and 9152 for 7700X. So
Yeah.
Zen 4 to Zen 5 is exactly the same. And again, that's a head scratcher, right? We do see a better uplift for 9600X Ryzen 5 versus 7600X Ryzen 5, but nothing really to write home about. Nothing to write home
Yeah,
about, right?
it's underwhelming, and again, it feels something felt off. You want to roll on to the next one?
Yeah, but again, we should probably mention again, Intel just generally does a little better here because Adobe has long, run better on Intel parts, and you can see that 14700K and 14600K are giving you a nice boost against their sort of their contemporaries. And also the interesting thing that's a point of reference that I like that Adam threw in here. Remember, again, because every CPU you do a test on adds more time, but that Core i5 14500 is a 65 watt part.
Oh, okay.
So you're looking at Ryzen 7 9700X versus that 14500, which is they're both 65 watt parts, but yet the i5 14500 is slightly faster. Not a huge home run there, but definitely, if you're looking at TDP versus TDP, of course, I'm sure the Intel part actually still uses more, even though it's technically 65 watt, but still, it's still the winner here. So clear win for Team Blue most of the time.
More apples to apples than the other than the 100 TDP CPUs.
Yep. Okay. Next one. Okay. So Push does give you more sub scores because it does have an overall score. But let's look at a little bit of the sub scores here. We won't get into the super detailed ones here for this. But, you could look at the extended long GOP, extended interframe, extended RAW. This is all video nerd stuff that, frankly, is well beyond me. I'm sure, like, Willis and Adam and Alex are like,
Gordon,
they get excited about it, but I don't get too excited.
Wait, are these
about
shorter is better or longer is better?
Longer is better.
Okay.
So, again, the contemporary for the 14700K, 14600K, generally better, those higher TDP parts. But, not a huge win. Not a huge win when you're looking at like the extended RAW performance. Well, actually, no, extended RAW is looking pretty good. But when you're like, sorry, this whole thing is, I'm looking at this askew on my screen here. But you're looking at, generally Intel having a little bit of a lead, but not a huge one. But again, looking at i5 14500, that 65 watt versus that 9700X, the advantage slightly would go to Intel for extended long GOP. Again, this is for video nerds. This is the things you look at, you care about. If you care about intra-frame performance, you pick the bar that you like, and then you sort of pick the CPU that you like based on that performance.
Yeah.
I would say a lot of these things are like so close it doesn't matter, but definitely long GOP seems to favor Intel. Looks like a little bit of intra-frame goes to Intel as well. Oh, did I script I should have colored that GPU effects a little differently. I use the same colored bar.
Oh.
I'll have to fix that.
Well, yeah, I mean, look, we're doing it live.
That's what's confusing me. But again, when you're looking at gen to gen performance, Ryzen 7 9700X is slightly faster than 7600.
It's the same
But
thing.
again,
Yeah.
it's not huge. You know, you do get a little more out of your extended GPU effects. You're getting 103 versus 102 for extended raw. You're getting 89 versus 88, 69 versus 65. Again, it's just like this again just sort of backs up the reason why we decided to sort of hold the review in the first place and do a retest. But, you know, we've decided after all the reviews this morning, you know what, let's just go with it because
Well, and I think we're still going to retest. We might not
Oh,
run the
yes.
full suite, but we're going to retest and see what we get with the, because we did learn some stuff along the way here is the
Yeah.
other thing.
yeah. Okay, let's go on and click on to the
This
next
is
one.
Resolve, yeah, is next.
This is Resolve. This is, of course, a much, and you know, I knock Adobe because basically there's stuff in Adobe Premiere that frankly is probably older than a lot of people watching this podcast. DaVinci Resolve is a brand new, very, very advanced video editor. It's got a lot of attention because it is way more advanced than Premiere in a lot of places, which is the reason why a lot of video editors like it. But when you're looking at this overall, you're looking at gen to gen again, 9700X versus 7700X. The 7700X is actually slightly faster. Longer bars are better.
Yeah,
And the 7700X is outperforming the 9700X
Yeah.
in this.
that seems weird.
So again, wacky, right? So we
Weird.
do see the
Yeah.
Ryzen 5 outperforming for Zen 5 Ryzen 5 outperforming the Zen 4 Ryzen 5 slightly. Not a huge advantage, but generally the Intel parts have a little bit of advantage overall against those AMD parts here. So basically Zen 5, Ryzen 7, Ryzen 5 are not looking too hot in DaVinci.
Okay, so here's the breakdowns for the individual scores in DaVinci as well.
Yep. So again, you know, you should, you know, if you only look at the main scores and you're a video editor, you should dig up as much data as you can because you do want to, again, find out the performance that you care about. You know, again, we have long GOP, we have interframe, raw performance, GPU effects, stuff that I don't really care about as a non-video nerd, but there are video nerds that care about it. We do have AI performance, but let's look at gen to gen, 9700X. So Zen 5, you're looking at 98 versus 98.
Yeah, and so Kafir in the chat asks if we were running manually tuned memory with F clock equals M clock, which we were. Just to be clear, PBO
Yeah.
was off for these tests, though, I believe.
Yeah, so we're going to get a little bit into a little bit at the end. We're just going to run through the last few benchmarks
Yeah.
we have just to get through them because it does feel like, well, people like, we didn't see your review. Let's go. Well, let's show everything. So basically, you can again see like the stuff like, you know, our Zen 5 parts were definitely not knocking it out of the ballpark.
Yeah.
Zen 5, Ryzen 5 versus Ryzen 5, same thing. Wasn't exactly, you know, outgunning that Zen 4 part again. You know, and there probably are reasons for that, and we're going to get into the end. And again, this is the reason why we didn't run the review this morning. But, you know, at this point, it's been such a mess. I guess it's been such a mess of everybody else's results. We decided to do it. But let's also compare that to the core parts and
Yeah.
you know, I would say these are pretty similar in performance. I would probably give the edge slightly to the Intel parts, but again, they do consume a lot more power than the AMD parts. But let's keep going.
Okay.
Let's keep going.
Past Photoshop.
Past Photoshop. Oh no, go to Photoshop.
Oh, go to Photoshop. Okay, sorry, I'd already.
Let's do
skipped ahead.
Photoshop. Oh, sorry, that was a detail shot for
DaVinci.
DaVinci, right?
Yeah.
So no, this is a Puget bench again running Photoshop. You know, overall still lightly threaded. You're not really hammering all the cores most of the time in Photoshop, despite what people think about it. But and again, this like the Zen 5 parts were not really doing it for us in multi-core performance, but in lightly threaded performance, looking pretty good.
Yeah.
Look, Photoshop longer bars better here. Photoshop 25.11 performance, 11,182 for Zen 5 in 9700X versus Zen 4 7700X. That's 10,346. So that's a decent uplift. You know, I mean, there's possibly even more left on the table if you were to you know, again, if we get our part to run a little better than it is, but you know, at least it is actually, matching what we sort of are seeing in lightly threaded performance, where you are getting a decent performance. What is that? Let's just pump.
It's like 10-ish percent, 10.
Yeah, so 10-ish% out of Photoshop from, gen to gen. I would say that's a success. To me, that's a big success to go. 10% in lightly threaded performance is very good. It is very hard to get, single threaded performance. So if you're getting 10-ish% out of the, Zen 4 to Zen 5, that's a win for them.
And the most clocks aren't 10% higher either. I mean, maybe the boost clock is, but the standard clocks are more or less the same, right? Yeah.
Yeah, and then again, you're still looking at chips, and again, this is lightly threaded, but overall, you're looking at a 65-watt part versus a 105-watt part. And then the most important thing for AMD here in Photoshop is 11,182 is better performance in Photoshop than a Core i9 14900K.
Yeah.
And that is a very, very high wattage part. And it's also outperforming 14700K, and the 14600K, which is its contemporaries in cost. So probably using less power and significantly outperforming those Core i7, Core i5 parts.
So can I ask a question?
Yeah.
Why is the 7900X slower than the 7700X? Is it because it's a multi-die, multi chip versus monolithic chip inefficiency, you think?
I'm not actually sure, because looking at that, it makes me wonder what's going on. I would have expected it to be a little closer. Yeah, maybe it's chip to chip, but
okay,
it could be. But again, this sort of points to it's entirely possible our 7900X performance here was affected by wherever was affecting our Zen 5 performance. Okay. Although, the Zen 4 performance, again, you're looking at Zen 4 for 7700X and 7600X, not doing too bad, right? Not doing too bad. They're looking better against their Intel contemporaries. And the 7700X is basically outperforming that 14700K, but there is, again, this is the reason why we sort of decided we need to retest some of these parts because things are a little weird. Yeah. But I would say overall, Zen 5 here does looks quite good, well against Zen 4 as well as against the Intel parts. So
okay, so here's the breakdown for the Photoshop slide.
Yeah,
as well.
We won't get super deep into the Photoshop. So this is just subscores, a general performance and filter performance, and you can again see the Zen 5, having a decent lead against Zen 4. Almost 9% over 7700X. You're looking at 6-ish against Zen 5 against the Zen 4 Ryzen 5, and all those Zen 5, Zen 4 parts are also nicely outperforming the Raptor Lake parts as well. So overall win here, lightly threaded performance, and I would say this is the kind of the thing that AMD was okay, this for AMD it's a good thing. For end users, I would probably want an AMD part based on these results.
Beating last gen's flagship with the 7 series part is pretty good. Yeah.
No, I think it's quite good. I have Puget Bench, the Adobe Photoshop stuff is fairly new. I would want to dig into a little bit more into this even detailed scores, but we got to keep rolling because people don't want to look at these bars any longer. Next one is Office Productivity. And this is basically Procyon Office running Microsoft Office, looking at performance in Word, Excel, PowerPoint, Outlook. Nobody cares about this except for IT people who basically Word, Excel, PowerPoint. This is stuff I can sell to my boss. I know people say that doesn't matter, but I don't believe that.
Look, man, if they can make Outlook launch faster, I'm in, right? That's the big test. Should we move on?
Overall, no surprises. I would say probably not a big deal here. They all perform quite well, and I wouldn't expect any of these parts to underperform in any of this. Although it does look like, I would say, interestingly, I saw this in Zen 5 Mobile, that Outlook AMD, we'll get into it a little bit later, but overall, it doesn't matter too much. Let's keep going.
There may be some other bottleneck on AMD machines, is what it looks like to me.
Yeah.
So Geekbench is next.
So Geekbench, this combines, this chart is single core and multi-core performance. I know a lot of people in hardware land turn their noses up at Geekbench. It can be still useful. And also, it's nice to include this because now people can officially argue about it on Twitter because now they have the results they can argue about. So single thread performance, this again looks pretty good for Zen 5. 3322 versus a 2908 for a 14700K. Very decent win against, again, a higher wattage part. And it's also outperforming that 14900K too. So that's pretty good single-threaded performance. Where Intel obviously outboxes AMD a lot of times is we give you more cores.
Yeah.
That's not always the case, but when you're looking at a Core i5 14600K versus a Ryzen 5 9600X, more cores are better. And frankly, the most people who are going to consume Geekbench and argue about it are going to go like, oh, longer bars better here. So,
okay. Next up is Crossmark.
yeah. So I included this one because I think it's kind of a fun little benchmark. AMD started including Geekbench, so I said, okay, we're going to include something that traditionally AMD's never used with Zen 4 launch. Intel has always been a big fan of, no surprise, Babco Crossmark. So I said, okay, I'm going to include Crossmark here. And we have our Crossmark results. And you could probably guess why Intel likes Crossmark because
yeah,
it outperforms AMD.
Real long,
right?
Yeah.
Yeah, and Babco is, there are a lot of different members of Babco. The way they do it is they basically they basically create these synthetic productivity, creativity, responsiveness test suites, and then they run on Android, they run on iOS, they run on Mac, they run on PC. Not Windows and ARM yet, but they basically run on all the platforms. So it is a cross-platform benchmark, which is useful if you want to use comparisons to Macs. But here we're looking at, Zen to Raptor Lake. Raptor Lake has the advantage. And then looking at, again, Zen 5 versus Zen 4, you're not getting that uplift you would expect here. But, they generally are at least a little bit faster, but I would have expected more out of it.
Yeah, 2081 versus 2096 is an insignificant difference in the
Yeah, so margin of error. So again, that points to the reasons why we had issues. And I would not have expected this because I really would have thought it would have been a little closer because it is a lightly threaded benchmark. But who knows? Who knows? Let's keep going.
Okay.
We're almost at the home stretch.
Now.
We're going to do a couple games here. Obviously, there's a ton of games. You can see those on Gamers Nexus. You can see it on Hardware Unbox. I don't know how Hardware Unbox can run 5,000 gaming benchmarks on launch day, but please, if you want to see gaming benchmarks until your eyeballs bleed, go over to Gamers. Go over to Hardware Unbox and watch a Steve video on it because you got to give credit to Steve for running 1 billion gaming benchmarks. This basically Adam Rand's 3D Mark brand new Steel Nomad. This is the overall score. Again, all of these are run on a 4090, and this benchmark is basically a GPU benchmark. And as all bench gaming GPU benchmarks are, there's basically no difference. This is basically probably maybe there was a light breeze in the room. One was a little bit cooler, so there was a change.
Yeah, the sun shines on the window in the afternoon, so it gets 3 degrees warmer in the lab. I don't know.
Yep. So again, it is a synthetic graphics benchmark, and we are getting the correct results for a synthetic graphics benchmark. And what I like is Steel Nomad. The results you're seeing here probably will be the same as you're seeing in 5 years if you put a 4090 into a machine. So that's what's useful. So that's why that's always a fun one and useful to record for history, because to go back and look at this 5 years from now, 10 years from now, this result will not change that much for 4090.
It's also useful to give you, it's another one of those sanity checks, right? It's another place that you're like, oh, if somebody's way off here, something's wrong with something in your setup, and it's worth digging into further. Anyway.
Yep. Okay, let's do just a couple. Cyberpunk. And overall, the winner is blue for the most part. But, frankly, if anybody could tell the difference between 165 frames a second versus 159 frames a second, I will give you an award. It's a no prize award, so you get no award.
Well,
so don't actually expect an award.
And this is also Cyberpunk tuned to be as CPU bound as you could make Cyberpunk, right? It's 1080p. It's running ultra, but with no upscaling, no DLSS, no FSR, no ray tracing on, again, a 4090. So it's
Yeah. And again, it is. It's trying to make Cyberpunk as CPU bound as you can, but again, the thing that is going to bug I didn't want to use a harsher language here. The thing that's going to bug the crap out of me is, again, Ryzen 7 9700X underperforming 7700X
Yeah.
here.
Yeah.
And why is Ryzen 5 9600X basically they're dead even,
Yeah.
right? 159 versus 159 again. It's just, again, these are the reasons why, our results were just funky and why we held them. And I feel a little better about publishing these results because, frankly, this is going to be one hell of a head scratch day for everybody trying to interpret all these results. But yeah.
Okay. So a couple more games. We got F1 2023. Again, this is a CPU bound as make it. This is actually a CPU bound bet. This is one of the only gaming benchmarks I think we've been able to find that we can really reliably make CPU bound. 1080p, high settings, no upscaling, no ray tracing, and on the Bahrain map.
Yeah, and then again, high wattage part win goes to Core i9. Intel likes to sell it as a gaming chip. No surprise, those high clocks do actually pay off in some games, and having the bigger bar is always worth it for that average person buying in a big in a big box store. And actually, here we sort of see performance better, where Ryzen 7 9700X outperforms Ryzen 7 7700X by a decent clip. Enough to probably say like, yeah, okay, we're outperforming it. And you're also seeing Ryzen 5 9600X outperforming Zen 4. So Zen 5 to Zen 4 performance looking fair here. And probably when you're looking at cost chip to cost chip, I would say, again, it's no big deal. But,
Well, I think it's interesting here. This isn't a super multi-threaded game. It runs a handful of threads. And I think it's interesting because the Core i9, like the Ryzen 7 9700X is competitive with the Core i9 at 400 frames a second. Like the 10 frames a second at 400 plus is like 2% or something. So yeah.
Right. And if you really want to get into the whole power thing, that i9 1400K is probably going to be consuming more power. I mean, people, they sometimes want to conflate things. If they see like a 1400K will eat 300 or 400 watts. Believe me, in gaming, it is not eating 300, 400 watts. I kind of sort of wish it would, because that would mean that our games are actually so heavily multi-threaded that 1400K is now suddenly using all of its cores. But frankly, it is not.
Yeah.
So most of the games are still very, very, very heavily GPU bound. Even though we try to tune these to be CPU bound as possible, most of the power budget is going to the CPU. So 9700X probably using less power, but not as little power as people think, because they think like, oh, 9700X will be using 40 watts here versus that 1400K at 300 watts. That's not the reality of it.
Yeah, both of the CPUs are going to turn off a bunch of cores and crank most of those cores way down and crank one or two of them really high.
Yeah, and that's because the games just simply don't use all the cores. So
Yeah.
people do need to keep that in mind. Sometimes the average gamer will just sort of look at peak power performance on the high-end Intel parts, and unfortunately, developers you could tell us they don't use all those cores. As a hardware nut, I wish we would, but they don't.
It turns out it's hard to keep a whole bunch of threads in sync in games with the way games
Right.
work. Yeah.
And then also, frankly, I'm sure business side would say, hey, it'd be really cool. I'm sure Intel and AMD would love it if you had to buy a Ryzen 9 or Core i9 to play our game.
No, they don't want that, actually. The game developers don't want that because they want to sell a bunch of copies of their game.
No, the game developers don't want it, but AMD and Intel would love it.
Well, they got to write checks if they want that to happen, man.
Right. So you don't sell a lot of games by saying, oh, yeah, you need a Core i9 or Ryzen 9 high core count game to play our game. That does not, believe me, that's like, hey, by the way, leave the office.
Yeah.
And then you'll be waiting in the CEO's, that little entry room with the secretary. And then security guard will show up with all the boxes of stuff.
The guys, the walls open behind you, get sucked into the walls, and you're gone then. Yeah.
Yeah, then they'll simply like, yes, no, we are not, the whole Crisis meme was actually not a good for the Crisis developers.
Yeah,
believe it or not. So.
No, you'll note that the Crisis 2 ran on potato computers. So.
Yep, they learned that lesson, didn't they?
Yeah.
So.
Okay.
All right, next one.
Next one is Tom Clancy's Rainbow Six Siege. Again, 1080p, DX11, no ray tracing. It's running at the 50% render scale up, not using DLSS or SR, just TAA, I think. And this is a little bit CPU bound too, I think.
Yeah, definitely more CPU bound. I mean, we're pushing 600 to 500 frames a second.
Yeah.
Um, and again, Zen 5 to Zen 4, yeah, fair increase. I do wonder. I would have expected a little more here, but that's still a fair increase, gen to gen, enough to at least say like, hey, we're giving you more. It's
It,
possible there's more. There's
yeah.
more juice left on that they can get out of it.
It moved. The bar is different.
Yeah, but you can also generally see that the Intel parts slightly outperform them. But let's be honest,
Yeah.
534 frames a second for a Ryzen 5 versus 531 frames a second for a Core i5 or 615 frames for Core i7. Come on, let's
Yeah.
get realistic here. It doesn't matter.
Okay. On with Total War Warhammer 3. This one is multi-threaded. This is a more multi-threaded game as an RTS.
Yeah, I mean, to me, it's quite a head scratcher because I do wonder if something is weird here because I don't know why that 1400K part is kind of like down to 200 frames a second. It feels like the performance should be higher.
Gordon, I think your x-axis is your scale is off here
Oh,
too. 'Cause
damn.
You're only going from 0
Oh,
220 to 270.
Oh,
So
that's
it's a
what it
less
is. Damn it.
pronounced difference than we should be seeing here, I think.
You know what I really love about this is the classic internet will scream, Gordon, I know you made the x-axis of this chart wrong intentionally because so-and-so vendor is giving you big fat checks.
Yeah.
But you know whose fault this is? This is Microsoft's fault.
Oh.
And I can firmly blame Microsoft because Excel will automatically, when you create a chart, randomly, because you can create every single previous chart. I didn't have to go ahead and adjust the x-axis. For this one, Excel decided to like, oh, let's just zoom in on 220 frames a
It
second.
just picks an arbitrary number, right?
But it doesn't do it all the time.
No.
It only does it sometimes, and then sometimes you don't catch it because, again, you're making these charts. You're burned out from having testing CPUs for 15 hours. But like, this is the classic, like, oh, you're in their pocket, Gordon.
Yeah.
But still, I still would have expected the 1400K to exceed the Core i7 and Core i5 though. So I still say that's correct.
Yeah.
But
Oh,
the
yeah,
but the nice thing here, of course, this is somewhat multi. I'll have to look at this benchmark, but it is somewhat multi-threaded. But interestingly, Zen 5 does quite nice. 264 frames for Zen 5 versus 253 is, again, that's a fair uplift. Again, there could be more juice left on the ground if we get these chips retested. To a couple things we're going to talk about in 1 second.
So I haven't spent a ton of time with this, but I think typically games are using 2 to 4 cores, and this is using a couple more, but not all of them would be my guess. So
Okay.
but we can roll on. Yeah.
Yeah.
So,
But this is like, yeah, okay, that's this. But,
oh, wow,
but again, this is like
a real graph.
this has been a hell of a launch cycle, right? Yeah, real graph here and the classic. Why do you keep throwing stuff onto this? Because it's like, oh, I need, and actually, I threw in the X3D parts. It's like, well, should I put in the KS parts too? It's like, and then pretty soon it's like, you're like, okay, this is like ridiculous. It gets ridiculous. I just kind of wanted to put in the specs of these, throw in this because it's interesting because, launch price versus the street price is always interesting. So, again, the Ryzen 7 9700X is a $359 part launch price. We'll see how it comes in at when it actually goes on sale tomorrow. But that's going to put it right in the neighborhood of what? i7 14700K to a 14600K.
Yeah.
So,
yeah.
and then of course the interesting thing, I included 13 gen parts. I wasn't going to originally, but this is probably a problem for Intel, but those 13 gen parts are still hanging around there like last week's Wonder Bread, right? They're still on the shelves, which is not good for Intel. But when you're looking at, frankly, not a bad chip. You're looking at a 13700K for $330.
I mean, 13700K probably okay. I'm gonna say personally, I have some feelings about the 13900K, Gordon. So
yeah, well, I mean, frankly, that applies to 1310. Well, 13700K, and it applies to every single Intel CPU you see in this list.
Yeah, that's true. That's true. Some seem more likely
Potentially,
than others
because remember, it doesn't apply to all of them. But although maybe not that 14500 part. So that is that low TDP part. I don't think that's on the list.
Yeah. So what did we find out? We got the weird numbers. We ran through the numbers we have. We're not super confident, especially in the heavily multi-threaded tests,
Right.
that they're actually reflective of the real performance of the chip. There's also the TDP question, right? Because this is, like you said, it's a 65 watt part. These are both 65 watt parts, and we're comparing them to last generation's 105 watt parts. So, did AMD say, hey, we're getting basically the same perf on lower wattage. We made the choice to not ship we could have run these at 100 watts and gotten a lot more performance, but since we're selling millions of these, we wanted to not, and no one's going to realistically notice that performance difference on the day to day. We decided to ship these, slow, or is that just, do you think this was a choice by AMD? Do you think there's a mistake? Do you think there's some bug in BIOSes? Why do you think this happened? I guess is the question.
You mean for our performance, or you mean the design decisions behind the chip
I
itself?
think for the performance that we saw in our testing, in our first round.
So
of
that
testing
I'm not
here.
getting guidance from AMD that said like, so, again, so typically as a responsible reviewer, you do all your testing, you start adding up the numbers, you're sitting in front of the calculator, the little papers popping out of the calculator. Wouldn't that be cool? Like you get those little,
Do you have a
you get
mechanical
that little
calculator
hat,
you're using
that
in there?
pencil
Yeah.
there. You're like,
You got your green brim hat. Yeah.
and you go like, what is going on here? So what I would typically do, and what I've done in the past here, and what we did here was like, hey, here's our number. Are we insane?
Yeah.
What is going? What is wrong here? And AMD's was like, your results are far off, are definitely on the lower end that we would expect. So again, this is based on the Cinebench 2024 results. Like, again, our numbers were 10% off of the sanity check numbers. Now,
It's
some people the sanity check numbers are simply there provided to you. Like, this is the ballpark you should be in. This is not simply saying like, here's the number, run our number. This is what you should be getting. This is simply saying you should be able to get within the margin of error of number.
Yeah.
Our number was 10% off of that, which was just wacky.
Yeah. So,
And
but I mean, I guess, so you talked to them. What did they say?
oh, so they basically said like, well, okay, maybe check out these things. Maybe you should be running, make sure you're running 1-to-1
F-clock,
on
M-clock.
memory.
Yeah.
Yeah, and then you should be running, again, for our testing, they basically ran, at 6,000 MT, and we're like, yeah, we're also running 6,000 MTs. And they also said like, well, see if the SoC voltage is too high. They basically said like, if your SoC voltage is at 1.25 on that board, you're probably seeing your SoC voltage running too high because it should be down at about 1.2.
So is that making it overheat and throttle? Is that the thought, or we don't know?
I don't know. I really didn't get into it because
Okay.
at that point, because we were making our decision whether to like let's just cut fish,
Yeah. Cup bait. Yeah.
cut bait, or and we decided to cut bait instead. And I don't really know, but my guess is it feels like the UFIs on some of these boards are not quite nailed down as I would have expected, because if we're getting our SoC voltage that is exceeding what they're sort of expecting us to get, then either it's our board, maybe it's a rev on our board, maybe it's our UFIs for our board that's just not quite right. They're basically saying our numbers are just off.
Yeah.
So, but they're basically saying, again, same RAM, the fabric, we're running 1-to-1, but our SoC was off. And so we basically, so again, I did mobile stuff. Adam actually did desktop stuff. And then I think we're doing additional testing, but I think at 1.2 volts, we are getting closer to expected results on some of these things. I won't get into any more, but I think we're getting closer to what we should expect.
Or what the sanity check numbers were, at least.
Yeah.
And that's also with, I think, PBO on for the most part.
So I mean, it's one of those things where, and this is the messiness of launches, because what are we testing here as a reviewer? Or should we be testing out of box what exactly the consumer gets only, or should we be setting some settings to get closer to, what the vendor should expects for the CPU to present itself.
Yeah.
So
Like the question is, are we testing for enthusiasts who are going to get into the BIOS and hit the overclock at minimum, hit the automatic overclocking button, or are we testing for the mainstream where, because these parts, especially these mid-range parts, end up in machines that are in Best Buy and stuff like that as well, right? And the people who are buying those probably aren't going to hit the overclock button. So
yeah, no, and although sometimes you may get that on some, some of the system integrators are doing a little tuning before they ship them to vendors, but I do think there is just a little weirdness that's going on when we retest all the parts, we should get closer, hopefully, to what's expected of these. And, again, our Ryzen 5 numbers, our Ryzen 7 numbers, we decided to hold. But now you're seeing our numbers because we frankly did it because you're seeing a lot of results from other reviewers that are like, whoa, our numbers are wacky too. A lot of the multi-threaded performance numbers were not great. I know that Steve over at Gamers Nexus, his Ryzen 7 part wasn't even stable enough for him to test. He felt like he wasn't able to present any results because it wasn't stable. For us, our performance was just simply, again, beyond expectations. Again, when you're 10% off what the chip should be performing, then it makes you wonder, like, if our samples are bad, if our board is bad, or UFIs are bad, or if we configured something wrong. And I will say, Paul Alcorn, I looked at his review. He actually got, again, somewhat similar to us. We're like, gosh, this thing gives you really, really good, lightly threaded, single-threaded performance. But in multi-threaded performance, it's not doing quite what I expected to. In fact, he was saying he never also got close to what AMD got for multi-threaded performance too. I think I clipped out the line. What did he say? I put it in our Slack channel as we were deciding this, but let me see if I can pull up this line from Paul Alcorn. What did Paul say? If I can find it. Oh, dang it. This conversation has moved on. Quote, we couldn't match AMD's guideline score for the multi-threaded Cinebench 2024 benchmark, lagging their reported score by roughly 5% for the 9600X and 9700X. Now, I will say as a reviewer, if we got 5% close enough, then I would say, like, okay, there's just, tolerance stack up. Yeah. Maybe it's the board, maybe it's a cooler, maybe it's just simply
like memory
it's Tuesday.
Or something. Yeah, it could be
something
anything.
is just a little off, but 5% is something I could live with. Versus sanity check numbers. 10% is something I could not live with. And that's the reason why we held it off originally. So, but if he was off 5%, and ours was off 10%, it's just simply wacky. And he actually did testing with the PBO off as well. And then he presented tests with PBO on. And actually his testing with PBO on looks like it's closer to what you would get out of these AMD parts out of their sanity check numbers. So there's just definitely a lot to unpack here. So
yeah, it's weird because I mean, people in chat are talking about the power draw on this, and we did, we have a watt meter hooked up to the machines when we're running benchmarks. We're paying attention to that. I don't think we have a slide for that. We may not.
No, not yet.
It's a little bit difficult to track reliably and repeatably. But we like. If AMD had said, hey, we're releasing these chips and they're going to be the same performance as the last generation, but at 30 or 40% less power draw, we would have probably tested a little bit differently and paid more attention to that. That wasn't part of the messaging for this, right, Gordon?
No, it wasn't. Because but then again, that would have been, and I would have expected if AMD had said, like, hey, you know what, we're just going to give all your savings in power, right? We're just going to save you all kinds of power. Love us because your electricity bill won't be as much. But that has not been the messaging because they have published many benchmarks over the last few months, indicating that these things are quite good at multi-threaded performance. And I think things are just simply off for everybody. And I'm not sure what exactly the reasons that it's off for everybody, but it feels like things are just simply off. And it's not just us, because I think Hardware Unboxed was quite unfavorable to these chips. Jay's 2 cents also quite unfavorable as well. So there's definitely some expectations that people expected better multi-core performance out of these, and they're just really, really disappointed by it. So I don't think that's the they if they'd come back frankly and said like, oh yeah, no, this is with what you should expect, then I think that probably would have been worse because a lot of the messaging for the last few months have been like pretty awesome power savings and pretty awesome, multi-core performance. And that hasn't been it. It's really been like pretty awesome power savings and also, pretty awesome multi-core performance, especially at the top end. But I do think, some of it is too, like it is something to be said. And, when we do our normal power graphs where we look at like how much power it's using, running all these different benchmarks, I think people will probably be suitably impressed because again, you're looking at a 65-watt part that is essentially performing on par, and hopefully when things are tuned up a little better with newer UFIs or people figure this out, it'll be outperforming a Zen 4 part at 105 watts. So again, that is something to be said that that's impressive.
Yeah.
But
they're not there now.
Again, we're not there now, and that's the thing that's sort of so vexing about this because people they really expected the multi-core performance on the chips on launch day, and we're not quite getting it there. And I have no idea why exactly, right? Because there's definitely some things and again, like I said, maybe the SoC voltage is maybe the motherboard vendors don't have it quite nailed down yet. Maybe they don't quite have their power budgets down for these parts. And you can imagine it's pretty hard to crank out more performance while using less power. And you're not moving from TSMC 5 to 4 isn't exactly a huge difference.
Yeah.
So, but it is a new grounds up chip. So, maybe this is something that in about 2 to 3 weeks, things will be like, okay, now we've figured it out. But
yeah, I was just saying
here and now.
So you think that's it? You think the next step is we'll get guidance from AMD about what went wrong or how to fix this performance gap? Or you think this is just where it is? You think this is just where it's going to land?
I think there's probably going to be a lot of people looking at the results now going, what happened? Because and again, I know the internet only has one setting and that's the blame. And I do want to say people need to get off of their outrage ponies. And I think you should we have to remember people who make all these parts, all these hardware vendors, they are for profit. They like to make money. And I say this again and again, because again, they are for profit vendors. They are here for the shareholders, but the people who design all these parts and make all these parts, they are no different than people who make software and the people who make games. There are people at all these companies that pour their heart and soul into it. And sometimes it doesn't come out the way on launch day that you would expect it to. Why that is because there are a million parts in motion. You basically have a lot of chips you're launching. Again, we're launching 4 chips at the same time because, the thing that's nutty here is that people are going to go like, well, maybe the problem is you launched the mobile part 2 weeks ago. So basically, I will tell you, I busted my ass on the mobile part launch. And then we now have 4 desktop launches.
Yeah.
Maybe the problem is you launched too many things at the same time. And I'm going to tell you, because the internet, on Reddit, on YouTube comments, people will say like, AMD launched too many things at the same time. You overwhelmed everybody. That's what the problem is. And then AMD's going to go like, do you remember the X3D launch where we launched the X3D parts? And we basically sent out this X3D part, and then we sent out this X3D part, and then we sent out this X3D part. We didn't just bomb everybody with the same parts at the same time because, one, maybe we couldn't send the parts out to everybody because maybe we didn't have all the boxes for the damn things. Maybe we couldn't validate them. And maybe the hardware reviewers don't want all the parts because they now suddenly can't review everything. So we're going to go from the internet yelling at them for saying, why didn't you give everybody all the X3D parts at the same time? You're trying to cover things up and scam us, to like, you shouldn't have sent all the parts to everybody at the same time. So I think that's maddening,
can't
because I will
win.
tell you,
Yeah.
you can't win, because this is not just AMD, this is Intel, this is Nvidia. They just get yelled at no matter what. So again, you're sending out 4 chips to reviewers. There aren't a lot of reviewers left on the planet anymore. You've got all the reviewers, you've got them spread across. You're doing a global launch. It is really hard to get all the documents, to get everything set up, make sure everybody has everything, to getting all the lawyers to sign off on this, make sure, like, you put this on paper, you send out to the reviewers, that's something that shows up in discovery if you ever get sued over something, because you know damn well the lawyers are going to go after those review documents. So please, please, please do not get on your high horse and just start screaming at everybody, because things don't always go right. At the same time, yeah, things didn't go right. I don't know why they went right. And yeah, maybe if you are a consumer and you're buying something, you're going to go, you know what, I'm going to wait and let this settle out for a couple of weeks before I want to buy something. That is totally fair to do, because if that's something, if it's got you spooked and it's your money, that is the right way to handle stuff. But I think the thing is not to get on it and just simply start screaming on Twitter, on Reddit, and just start crapping on everybody's head saying, Bob, but you should have done this, you should have done that. It's like, oh, it's not great. Please don't do that. At the same time, if you're spooked enough to go like, yeah, I'm going to wait before I buy something, that is probably that is your right to do that with your money. So, and that's probably the right thing to do at this point.
Yeah. Okay. Well, I think that's as good a place as any to wrap it up. Unless you, I think nobody ever went wrong by waiting a couple of weeks to see what happens before they bought a new CPU. It turns out.
Yeah, especially because it's, again, the classic thing is like, the good thing here is it's like, oh, okay, because clearly this launch did not go over as smoothly as I think it was probably hoped for, I would imagine. But we're not gonna have on the classical, people are not gonna be on Twitter, on Reddit and yelling, oh, you should have bought an Intel part, right? Should they have bought an Intel part? Because
look, I'm going to go tell you, like two 13900Ks in the course of doing these benchmarks. It turns out we torched a 14700K as well. It looks like, and maybe a KS, which I don't think we benchmarked here. But anyway, yeah, like, no, I don't think anybody should probably go out and buy 13th or 14th gen Intel right now, because of the up in the air system of the up in the air nature of the fix, the proposed fix for their instability problems, right? So if you have to buy something right now, Zen 4, Zen 5 seem like the thing. Like, if you need a computer tomorrow, Zen 4, Zen 5 seem like the right choice. Is it? Are you going to be thrilled with the performance? Is your Zen 5 machine going to be worth a premium over a Zen 4? I mean, maybe if you don't want your PC to be a space heater, but other than that, it seems like they're roughly equivalent. So at least as we stand right now. And I guess, like I always say, buy the thing that you know you're buying today, rather than what you're hoping will be fixed for tomorrow or improved for tomorrow. It's because the future is impossible to know, and they may figure out, it may be that there's a new BIOS next week for these boards, for these AIM-5 boards, that makes these things perform 10% faster than our benchmarks indicated in multi-threaded stuff, right? Like that is definitely on the table as a possibility. But would I bet on it? No. I'm in the business of telling people what to buy today.
Yeah, no, that's our job. Although I will say this is a great opportunity. I will tell you right now, although it doesn't necessarily apply because these are desktop parts, but because I know the spirit of the internet is only team sports. Please, Apple fans and Snapdragon X Qualcomm fans, please feel free to come out and now and just simply dance on everybody's misery right now, because that is the way to do it.
Are there Snapdragon X Qualcomm fans, Gordon? I've never met one of those yet. I've seen Apple fans before, but I've never seen a Snapdragon fan, I don't think.
They actually are out there, I'm noticing, because I'm now getting it from people I would say they're not really Snapdragon X fans, but they're sort of like Windows on ARM fans, or basically the ARM fans that have run an ARM on Windows. They are out there, and they have been like dancing on everybody's heads. Although Zen 5 Mobile's kind of taken a little bit of a shine off of that, but
Yeah.
they definitely are out there, and they definitely like to you should have, Windows on ARM, power savings. But clearly, the big opening is for Apple fans. So please, Apple fans, you have my permission to get on X.com, Reddit, and YouTube comments, and you say, "Oh, you should have just bought an Apple. See, you should have just bought an Apple." But just know that that probably means you're going to tempt fate, because anytime you start singing your team's praises and saying how much better it would have been to buy your team stuff, you're now going to cause some horrible misfortune for your team, because suddenly Apple's like, you know what, we're not going to do a M4 part this year, because it looks like we're heading into possibly some economic headwinds, and maybe a Zen or maybe an M4 mobile part. Maybe we'll wait till next year. So I think you want to be careful there, because you're gonna invite that kind of misery if that happens.
Yeah, and nobody ever wants to be wrong on the internet. That's how we got in this situation in the first place. So
Yeah.
I guess I guess that's a good place to wrap it up for today, Gordon.
Yeah, I think we're good, unless there's kind of burning questions. No, we haven't missed any.
I mean, there were
no.
people asking about questions earlier that left, but I think we've been going for an hour, and I have some.
Oh, jeez.
I have some work to do in the back behind me here. I think you probably do too. So
I've lost track of time.
we will. I mean, I'm sure we'll be talking about this more on Full Nerd next week, and there'll be more videos about Zen 5. We're going to do a benchmark video, a full review for the Ryzen 5 and Ryzen 7 at some point in the not too distant future. We just have to get the benchmarks back. We just have to redo a bunch of benchmarks, is the kind of TLDR. So anyway,
Yeah. So please wait. I think there's more to come. So don't. Again, this is a day one launch that is a little messier than expected. So keep your eyes out. We're going to be updating our stuff. I'm sure others will be updating their stuff too. So this is not the end. This is not the end.
yeah. Okay.
Keeps going.
Well, see you all next time. Thanks for watching, everybody. And thanks, Gordon. Always a pleasure to chat with you.
Well, it was fun. Thanks for hosting.
Okay. See y'all.